I'm not as think as I smart I am. I'm not as think as I smart I am. I'm not as think as I thought I might be, for that's clear anybody to see. I'm not as think as I smart I am. I'm not as think as I smart.
Welcome to the final episode of Brains Matter for 2006. This is episode 11 for the 20th of December 2006. I'm the Ordinary Guy, and I'll bring you stories on science, curiosities, knowledge, and anything else that's interesting. On today's show, I'll feature stories on the scientific definition of theory, a listener question, the pin of the week, and I'll bring you some of the latest news in the world of knowledge. And just before I get on with the show, I'm looking for a new icon still, so if you're the creative sort, put something together and submit it, and it may become the new icon for Brains Matter. I had an email from Marcus in Melbourne, Australia, asking about the differences between the definition of theory normally compared to the scientific definition of theory. This was after listening to a story in episode 2 where I didn't explain myself very well. Many people who try to argue against certain elements of science, for example evolution, point to the fact that people use the term theory for it and mistakenly presume it means something similar to colloquial use of the word. In other words, they think it means educated guess. Dictionary.com has amongst the definitions of the word as being contemplation or speculation and guess or conjecture. In science, however, theory is an explanation based on observation, experiments or reasoning, and has been tested and confirmed as a general principle to explain the facts. A theory is an explanation that interprets the facts. Facts can't be argued. For example, saying, the apple on that table is red is stating a fact, if indeed the apple on the table is red. If the apple drops off the table, however, the reason for the apple falling is due to our understanding of gravity. However, gravity itself is a theory. A theory, as I said before, is an interpretation of facts. The Newtonian theory of gravity was a reasonable explanation of the observed effects, but was replaced by a better theory, which was the Einstein theory of gravity. Both explain what you see and what you observe and what the effects are, both future and past, and also of the present. Perhaps Einstein's theory will be replaced in the future, maybe by something involving superstring theory. However, the theory of gravity doesn't make it untenable or not a representation of reality. This is where the whole discussion of evolution versus other things come in. And the other things are generally based on religious mythology and not anything based on observation, whether that be facts or theories. A theory, as I mentioned before, is based on facts and it has to be stated in such a way that it interprets the facts and, most importantly, can be falsified. In other words, it has to be able to be disproved. If it's stated in such a way that you can't disprove it, then the statement becomes invalid. It becomes a statement of faith and not one of fact. Therefore, taking one set of religious mythology as an example, and that being creationism, nobody can ever be honest and claim that it's a theory based on fact, or factual in itself. Nobody can prove creationism, and nobody has, and on the flip side, nobody can disprove it. It's an article of faith. Before I go on, I'll just comment on something. What bemuses me is that in this type of discussion, many people in the Western world think it's only a creationism against evolution discussion, taking a Judeo-Islamic Christian view. One must keep in mind that this is just one religious view amongst many. There's the Aboriginal Dreamtime, the Hindu and Vedic views on existence, perhaps hundreds of religious explanations of the universe. There's far too much attention paid on creationism at the expense of the others. If you were to promote religion at the expense of science, then you've got to be fair. You have to be able to discuss all religious viewpoints, not just the Judeo-Islamic Christian one. I restrict myself to a discussion on evolution and creationism though, because that's what seems to be getting most of the press. So much so that in some places in the world, such as Kansas in America, schools have been instructed to teach creationism in science class, which is actually quite laughable. Science is science, and religion is religion. Pretending that creationism is different under the name of intelligent design won't fool anyone with any common sense. What disappoints me is that those on the anti-evolution side who claim that evolution is mutually exclusive to their perspective, and those on the evolution side who also think that religious mythology is mutually exclusive to their perspective, are being very closed-minded. Many scientists have religious beliefs. You find scientists of all religious backgrounds around the world. And of course, many scientists don't believe in any higher power other than that of the natural world. Lots of people think that if you believe in some religious form of the existence or creation of the universe, you can't believe in evolution. And some think that if you believe in evolution, it comes at the expense of religious views. Neither is true. Who's to say that the Big Bang wasn't a moment of creationism? Or perhaps there have been multiple Big Bangs in the past, which is a valid scientific theory at the moment, and that conforms to other religious views about the perpetual existence of the universe. We must also keep in mind that what is written in religious texts tend to be allegories to reality, not literal transcriptions. So in summary, my view is that the argument is stupid. There's not much doubt that evolutionary theory is based on solid facts. It explains almost all biology and medicine today, and if it wasn't the case, there have been millions of flukes in a row, and medicine as we know it wouldn't work. But it also doesn't mean that one can't have faith in a religion of their choice or no religion at all. It doesn't really conflict with each other. Those who think that it does are probably missing the point. So thanks for your email, Marcus. I hope that helps expand on everyone's understanding of the definition of theory from a science perspective. And now it's time for today's brain teaser. What does a muscle have to do with a mouse? The answer to the brain teaser later in the show. No tomorrow, no tomorrow. Find it kind of funny, find it kind of sad. Dreams in which I'm dying are the best I've ever had. Find it hard to tell you and I find it hard to take. When people run in circles, it's a very, very I received an email from Andrew in Mount Eliza in Australia. Andrew asked, assuming that in the future humans will be capable of propelling ships in space at near the speed of light, what effect would this have on humans on board these ships? Presumably the ship could not accelerate at more than about 2g without causing crew discomfort. How long would it take for an object to reach the speed of light if it's accelerating at 2g? Well, I'll answer the second part of that question first, Andrew. If we assume an acceleration rate of 2g, in other words, twice the acceleration of gravity, from standstill, then we could approximate the answer by using the formula s equals at. In other words, velocity equals acceleration by time. We're not particularly fussed with the direction here, so we'll say speed instead of velocity. For those who don't know, speed and velocity are actually different in size. Velocity has a direction, speed doesn't. We can work out how long it would take to hit the speed of light. Well, I know matter can't reach the speed of light itself, but we'll say close enough. So I'll still use 3 by 10 to the 8 meters per second, or in other words, 300 billion meters per second. So divide 300 billion meters per second by twice the value of g at 9.8 meters per second squared times 2, or in other words, 300 billion meters per second divided by 19.6 meters per second squared. Solving this, you get over 168 billion seconds, which works out to be around 5.5 years. To give you a comparison, a sports car that can hit 100 kilometers an hour in 5 seconds puts an effect of around half a g on your body. The first part of the question is a bit harder. I'm not a physicist, but I would think that if you assume they started accelerating from rest while in space, they would feel the acceleration. The easiest way to think about this is the formula F equals ma, or in other words, force equals mass multiplied by the acceleration. As long as there's an acceleration, either positive or negative acceleration, or known as acceleration and deceleration to the average person, then the people on board would definitely feel the effect. If the craft stopped accelerating, however, then they wouldn't be able to tell if the craft was moving or if it was totally still. Think of F equals ma again. If a, or the acceleration, is 0, the force on their body is 0. So even if the craft is going at 95% the speed of light, there's no external force on your body. So I hope that answers your questions, Andrew. Keep those emails and questions coming in. Now it's time for the answer to the brain teaser. What does a muscle have to do with a mouse? Well, when the ancient Greeks watched athletics, they thought the rippling motion of muscles on the athletes looked like a little mouse running under the skin. The Romans then caught on to this idea, and they started using the word musculus, which means little mouse. Musculus then became the word that we use today, muscle. Now it's time for the pin of the week. Today's pin of the week goes to Marianne from Canada. Thanks for adding to the Frapper map, and I hope you're enjoying the show. And if you want to become part of Pin of the Week, it's easy to become eligible. Just put down a pin with your name and location into the new Frapper map, just like Marianne did. And now it's time for some news from the world of knowledge. According to a study in the November issue of Animal Behaviour, researchers have discovered that chimpanzees associate particular sounds to certain items, especially food. In other words, they have, well, words. A very basic language, so to speak. Our analyses surprisingly showed that grunts to banana, bread and mango were acoustically distinct, said Klaus Zuberbühler, a researcher in the School of Psychology at the University of St Andrews in Scotland. The team studied chimpanzees at the Edinburgh Zoo, as well as chimps in the wild at Budongo Forest Reserve in Uganda. Who knows? Maybe the story of Dr. Dolittle and talking to the animals isn't so far-fetched after all. And now it's time for a joke. A hydrogen atom walks into a bar in a panic. The bartender turns to him and asks, "What's wrong?" "I think I've lost an electron," replied the hydrogen atom. "Are you sure?" asked the bartender, to which the hydrogen atom replied, "I'm positive." Thank you once again for listening to the Brains Matter podcast for the 20th of December 2006, which is the last one for the year. And thanks for sticking with me and showing all the support you have so far. Brains Matter ended up getting to number 3 in the Australian iTunes store in the science category a couple of weeks ago. It's sitting happily at number 9 now. You guys have made the show what it is today. I'll aim to improve it in its second year, and I hope you continue to enjoy it. I know it was a short show, but I wanted to get something out for you guys and then start packing because I'm going on holidays this week. If you have any comments, questions or suggestions, please keep that email rolling in at mail@brainsmatter.com or leave a comment on this episode's show notes at www.brainsmatter.com, and make sure you let me know where you're from and how you found the podcast. You can find the older podcasts on the Brains Matter site. Just click on the podcast link on the right hand side. There's a bunch of other stuff on the website as well, so go check it out. If you enjoy the show, you're most welcome to donate via PayPal. That'll allow me to continue to produce the show and help out in terms of internet and other costs. Music on today's show comes courtesy of PodSafe Audio, and you can find the podcast by doing a search within iTunes or by subscribing manually by clicking one of the links on the website. Please leave comments and vote for the podcast in iTunes and Podcast Alley. If you already voted in Podcast Alley last month, make sure to vote this month as well. I'll leave you with a quote from Anwar el-Sadat. "I was brought up to believe that how I saw myself was more important than how others saw me." I hope you enjoyed the show. Have a safe and happy summer, or winter if you're on the other side of the world. Season's greetings for whatever you do or don't celebrate, and a happy new year to you all. Brains Matter will be back in January, so be safe, and you will hear from me in the new year. Bye for now.
I'm not as think as I smart, I am. I'm not as think as I smart, I am. I'm not as think as I thought I might be, for that's clear anybody to see. I'm not as think as I smart, I am. I'm not as think as I smart, I am. I'm not as think as I clever I would be, I'm not half as clever as me.